So today we're going to talk about linear inequalities, and I will say that dealing with inequalities and specifically being able to graph inequalities onto a number line is a skill that we're going to continue to use like into calculus. So it's worth dealing with, and we're like starting with linear inequalities, but we will deal with nonlinear inequalities also. And I'm kind of going to choose to start the graphing on a number line thing now, even though it's not so important for the linear inequalities, it will be when we're doing the nonlinear ones. So it's just easier to get that practice in now. So the whole idea of an inequality is that something is either bigger or smaller than another thing. Just symbols wise and kind of how we read them. If I wrote X, and then it's kind of like we took an equal sign, but we squished a side of it together. We typically read this from left to right, and from left to right, I would say X is greater than 4. And I don't know if they still teach this in school, but when I was a kid, they said the alligator eats the bigger thing. And so do they still teach that? Nice. So this symbol, it's like an alligator and it's eating the bigger thing. I don't know. The truth is that I can take this same line, and instead of reading it left to right, I could choose to read it from right to left, but then everything switches in the inequality. So if I read this from right to left, this would say 4 is less than X. And it's okay to read it in either direction. This is the more standard direction to read it in. And because of that, we call this one the greater than symbol. Because if I'm reading from left to right, I would use the greater than. If I had something like -3 is less than 0. So this one, if I'm reading from left to right, I would read as -3 is less than 0. One of the reasons that I wanted to bring up the negative number thing is that and maybe it's just me, but I've kind of always had trouble with thinking about the comparison of, let's say, -5 and -1. 5 on its own is bigger than 1. But when we're using this inequality notation, what we actually mean is who is further left on the number line. So when I'm talking about number line, I'm saying we sort of imagine that there is this continuous line of values stretching from -infinity to +infinity. And all of our numbers are like ranked on this number line from left to right. And so if I marked out 0 in the middle, all of the negative numbers are on the left-hand side of 0. And this would be like -1, -2, -3, -4, -5 would be over here. And because -5 is further to the left than -1 is on the number line, we say -5 is less than -1. Okay, good times. Let's talk a little bit about this number line. You do not need to draw in a whole bunch of little tick marks. You do not need to draw in a whole bunch of numbers. You don't even need to put 0 on the number line. If I said something like X is greater than 4, and I wanted you to graph that on a number line, the only thing I need to see is 4. And then a direction that X is headed. So if X is greater than 4, then I'm thinking about which side of that 4 are the numbers that are greater than 4. So on the right-hand side, so I would kind of shade this in. Now, another point about graphing, when I graph this inequality, I have 2 choices to show that it's a greater than. I can either use parentheses or an open circle. Good times. And that's just a way of graphing all of those possible X values. Move that up just a teeny bit. So let's say that I had X is less than -3. And again, -3 is really the only thing that has to go on that number line. I'm going to put parentheses and sketch it in this way. Now, the reason that I'm choosing to put parentheses there is that there's another notation for this inequality that represents all of the X values over here. And we call it interval notation. And that notation is used a lot in pre-calc and calculus. And when we think about that interval notation, it's sometimes helpful to actually write in the -infinity and +infinity onto our number line. Because in interval notation, there's not an I in there. I don't know. It's Monday morning. Can I blame that? Notation. There we go. In interval notation, I would say that X exists between -infinity and -3. And it's important that I'm putting parentheses on that, meaning like rounded curvy things, not square blocky things, because those parentheses mean that I had an inequality. Notation wise, if I wanted to also include the value of -3, I would have to write something like X is less than or equal to -3. So we read this symbol as X is less than or equal to 3. And when we have that or equal to part, then when we draw it on the number line, for starters, here's my -3. And if we have the or equal to part, we should have either a closed circle or you can also use square brackets. And in interval notation, we would write this as -infinity to -3. And we put a square bracket on it, which means we do include 3. Now, really, none of that was particularly mathy. That's just notation stuff. But it's notation that's important for being accurate in our answers and making sure that other people know exactly what our answer is saying. Okay. Now, let's actually solve some inequalities. This was all just sort of how to write our answers when we get to an answer, but let's have fun solving some inequalities. Three x plus 4 is less than 1 minus 2x. So when we're solving an inequality, we basically pretend that that was an equal sign. And as long as we do the same thing to both sides, we haven't changed the problem. There is a catch. And some of you may remember this rule about when you multiply by a negative number. Anyone remember what you have to do when you multiply by a negative number? Yep, totally. You flip the inequality sign. Now, that's one choice of how to think about it. And I'm going to show you another choice of how to think about it. It is important to know both. It's important to know it as a rule, and it's important to be able to deal with it. But so what I would do on this problem, I know that I'm trying to get the x's by themselves on one side and all the number stuff on the other side. So I would look at this and say, which side can I put my x's on so that they show up positive? Which side? Do I need to put them on the left or the right? So I'm going to go ahead and add 2x to both sides. So I now have 5x plus 4 is less than 1. And then I can subtract 4 from both sides. And have 5x is less than -3. Now I'm going to divide by 5. Totally fine to leave our answer with a fraction. But if I asked you to sketch or draw the solution or graph the solution, this is going to look like, we'll get our number line. I'm just going to plop -3/5 on there. And because x is less than -3/5, I know I'm headed to the left. It does not have the little or equal to bar at the bottom. So an open circle or parentheses will do. Now for the same problem, let's pretend that you looked at this and said, I don't know, you looked at it and you were like, I'm going to subtract the 1 from both sides. Good morning. I'm going to subtract the 1 from both sides. So I'll have like 3x plus 3 is less than -2x. And then subtract the 3x from both sides. And have 3 is less than -5x. Well, if you got to here and then the coefficient on that x is negative, if you divide both sides by -5, you would have to remember to flip the sign. Now, the reason that you're having to flip the sign is because essentially you picked the wrong side to put the x's on. So when I divide by -5, in order to preserve the correct inequality here, we have to flip the sign like that. Now, just as I was pointing out on the notation side, if I read this from left to right, it says -3/5 is greater than x. But I can also read it from right to left, and it would say x is less than -3/5, which is the same answer that we got over here. For me, I think this one, it's a little bit, I know it's a small thing, but when I'm trying to graph this one on the number line, for whatever reason, in my head, it's harder. So if I end up with my x's on the right-hand side of the inequality, I pick the entire thing up and flip it over to make that say x is less than -3/5. Because for whatever reason, that's just easier for me to go, oh, x is less than, that means to the left of. Keeping an eye on the chat in Zoom. Got no questions over there. How's everybody feeling in the room? Got another example going? Because I know how much we love fractions. It's just a known fact. Fractions are fun. Let's have 2/3 of x minus 5 is greater than or equal to x minus 9/2. Okay, so I've got 2/3 of x minus 5 is greater than or equal to x minus 9/2. And when I walk up to this problem, I see fractions. And I'm like, yeah, let's multiply by something to get rid of those. So I'm going to choose to multiply both sides by 6 to make sure that we get rid of all of the denominators. So I'll give you a second to do that on your papers. But go ahead and multiply both sides by 6, making sure to distribute that out. And then you can decide which side of the equation you want your x's to end up on. Have an answer, you can go ahead and put it in interval notation and graph it just to practice all the things. Would anyone like a minute to keep working on it on your own? Mess with it together? Okay. So looking on the left-hand side, I do have parentheses and then something that's broken up by addition or subtraction. So that means that I know I'm going to have to distribute. So that's 6. I'm having fun with my colored pens today. That 6 is going to distribute in here and here. So when I distribute 6 into this first piece, that's going to look like 6 times 2 times x. All of that's on the top and 3's on the bottom. And then when I distribute here, 6 times 5 is going to give me 30. You do not have to write out this intermediate step. I'm just doing it for completeness. Since 6 divided by 3 is 2, I can turn that 6 divided by 3 into a 2. And now I have 4x minus 30. Totally fine if you want to go straight from here to the 4x minus 30. We do the same thing on the other side, distributing in the 6. Then I've got 6 times x and 6 times 9/2. So 6x minus 9 times 6 over 2. And that 6 over 2, 6 divided by 2 is equal to 3. So I'm looking at 6x minus 27. So if I were doing this, I'm going to look at that and say, I want my x's on the right-hand side so that the coefficient on x turns out positive. It doesn't actually matter which way you do it. That's just my personal preference. So I'm going to subtract 4x from both sides. And just to be efficient on the same line, I'm going to add 27 to both sides. On the left-hand side, that's going to leave me with -3. And on the right-hand side, I'm going to have a 2x. So I am looking at x is less than or equal to -3 halves. And I'm going to do the same step that I did last time. You do not have to do this, but for me, I prefer to be looking at like the mirror image of that to say x is less than or equal to -3 halves. It's just easier for me to see that number line piece. Because we have that little or equal to bar, I know this time I'm going to have brackets instead of parentheses or a filled in circle. If you like the filled in circle notation, I'm going to have a filled in circle and then headed to the left. Or in interval notation, I'll go ahead and put my negative infinity and positive infinity on here. That means that I'm looking at negative infinity to -3 halves with bracket. No one asked this before, but anytime we have positive or negative infinity, we always use parentheses, never a bracket. And that's part of our like math notation and saying infinity is not a particular number. I can't actually get to that particular number. It's this concept of the thing that's way, way out there on the end. Questions about this guy before we do another example? We're having so much fun. Okay, yeah. Oh, you certainly don't have to, but the alternative is ending up needing common denominators. So for me, I looked at the problem and I said, okay, I've got a thing with a denominator of 2 and something with a denominator of 3. So I'm going to choose to multiply both sides by 6 so that I don't have denominators to deal with. You could also, I know it's still multiplying by 6, but you could think about it as multiplying by 2 and then by 3, or multiplying by 3 and then by 2. Like you can take care of the denominators one at a time, and that's totally fine also. Let's do another example with fractions just to practice that. I made this one a little extra messy just for fun. And this time, I'm going to look at that and I'm going to say, well, I either have to get common denominators or I have to get rid of the denominators. And anytime I have an equality or an inequality, I have the choice of multiplying both sides to get rid of the denominators. And that's usually my choice. So right now I've got denominators of 2 and 5, which means that my lowest common denominator is 10. And I'm going to multiply both sides by 10. Or you can multiply both sides by 2 and by 5. So 7x over 2 plus 1 greater than -4 minus x plus 1 over 5. And I'm going to multiply both sides by, and this time I'm going to write it out as 2 times 5. Should I give everybody a minute to distribute in on your own? Okay. on my handwriting, maybe made that look like a 2.5, but it's just 10 in disguise, 2 times 5. See a few people still writing. But I think I'm gonna go ahead and start messing with this. So I'm gonna do that intermediate step again. So when I distribute the 10 into both pieces, when I distribute to the first piece, I'd have 2 times 5 times 7x all over 2. And there's my 2 over 2 that becomes a 1. And I have 35x. When I distribute the 2 times 5, which is secretly 10, into the 1, then I've got 10 is greater than. I'm going to do the same thing, throw my pen, and then 10 times 5, sorry, 2 times 5 is 10. So when I distribute that into the -4, I've got -40. And then this next one, I'm going to be super careful about. So when I distribute in here, the issue is that subtraction is subtracting this entire piece. So I'm going to do this in 2 steps. And I'm going to think about this as subtracting. I've got the x plus 1 over 5. And now I'm distributing in the 2 and the 5. So my 5 over 5, that became a 1. 10 greater than -40. And here, I have a negative sign to distribute and I have a 2 to distribute. So I'm going to end up with -2x minus 2. This is one of those super common places where our brain just does the wrong thing when it sees that minus sign. So and it's just unfortunate that that's how our notation is, that when you're subtracting a fraction and there's like garbage on the top and garbage on the bottom, you can put that minus sign out in front, or you can put that minus sign on top, or you can put that minus sign in the denominator. If it helps you to see it, just one kind of alternate option here, that minus x plus 1 over 5, you could turn into plus x plus 1 over -5. These two are equivalent. And I find that people tend to make fewer mistakes with this one. But just totally up to you and kind of how your thought process goes. Okay, now I'm looking at this and I'm saying, which side should I put my x's on so that the coefficient ends up positive? And in this case, I want them on the left. So I'm going to add 2x to both sides and subtract 10 from both sides. So on the left, I'm going to end up with 37x. And on the right-hand side, I've got negative 10. Sorry, I pointed at negative 40 and said the wrong thing. Negative 40 minus 10 puts me at negative 50. And then minus 2, I'm going to be at negative 52. So it's gross, but x is greater than negative 52 over 37. Now we could do a quick check and ask ourselves, hey, is that in lowest terms? But the 52 for sure is going to be divisible by 2. I can't think of anything that goes into 37. Pretty sure it's prime. So that's it. That is in lowest terms. And I can put this on my number line, negative 52 over 37. And if x is greater than, I know I'm on the right-hand side, then we can either use parentheses or an open circle. So if I were writing this in interval notation, I could say negative 52 over 37 with parentheses, comma, positive infinity. On the quiz, I definitely will ask you to graph it. I don't care which of these notations you're using. You can use the inequality notation or the interval notation. Yeah.
And so when you use the normal,
it's actually because of the lack of an or equal to. So like just notation wise, we use brackets when we have either the greater than or equal to or the less than or equal to. We use parentheses when we have a strictly greater than or less than, or anytime we're talking about negative infinity or positive infinity. The positive and negative infinity always get parentheses no matter where they show up. Yep. And I guess just to add to the notation, this would also be like a filled in circle, and this would be an open circle. We might also have something that maybe looks slightly more complicated, but isn't a whole lot more complicated. Maybe I will have something, let's start off slow. So 0 is less than or equal to x plus 4, which is less than 10. I could make up some sort of word problem-y thing where this is what we would write. So I could say 4 more than a number is greater than or equal to 0, but less than 10. Bottom line is, if I'm asked to solve this for x, meaning to get the x by itself, we have 2 pieces to the inequality. But the same sort of rule holds that as long as I do the same thing in each of our three pieces, we won't have changed the problem. So I'm going to go ahead and subtract 4 in the middle to get the x by itself. And that means I have to subtract 4 on both of the sides. 0 minus 4 is going to leave me with -4, less than or equal to x, less than 6. So if I were graphing this time my number line needs 2 pieces. I need a -4 and a 6. And x is in between the two. And then I somehow need to show that I do want to include the -4. So I'll go ahead and use a closed circle, but I do not want to include the 6. So I'll use an open circle at that end. Or if I were writing this in interval notation, I would include the -4. But instead of going like all the way to positive infinity this time, we're going to stop at 6. And the 6 would have parentheses because it is not included. Yeah. Excellent question. Somebody pick a number, any number between -4 and 6. 3. So if we take 3 and we plug it into the original inequality, we hope that it's true. So yeah, 7 is greater than or equal to 0, but it's also less than 10. I'm not sure if that's what you meant, but that is one way that you can check your work. For this particular one, it wasn't that complicated, but if it were messier, this is, this is a good way to check it. We can do it for one of the more complicated ones too. I will tell you that I like to plug in 0 because it's usually easy to mess with the problem if it's a 0. So like if we go back to the previous one, that's kind of gross. But whatever it is, 0 is over here for sure. Because it's some kind of negative number. So 0 is over here for sure. So if I were to go back to the original equation and try plugging in 0, like, let's test 0. Yeah, I actually wasn't writing anything at all. That's why. Yeah, I know. But 0 is over here. So I was going to come up here and test 0. So if we test 0, then I've got 7 times 0 over 2 plus 1. And I want to know, I always put a little question mark over it if I'm like checking something, because I don't want to say it is for sure bigger. We're just testing if it's bigger. -4 minus 0 plus 1 over 5. Well, that's 0. So is 1 greater than -4 minus 1/5? Yes, for sure. 1 is bigger than some negative garbage. Good times. I see people still writing, so I'm gonna leave it for a second. Help me. So, okay. So, yes, there are words, I suppose that technically makes it a word problem, but just for some practice, the length of a rectangle is 5 less than twice the width. If the perimeter must be at least 100 feet, what are the possible values for the width? I don't know if we've talked about this and word problems, but one of the things that I have found helpful over the years about word problems, if you're not sure where to start, dissect the grammar of the word problem. Here's what I mean. Start backwards, find the question word, and then figure out what we're doing. So I'm going to start backwards at this question mark, and I am going to move in the clause until I find something that's a word, some sort of verb that's telling me to do something with the 4 values possible, the are what. Here's my question. So we're being asked to find what are the possible values for the width. So our final answer is going to be something like width equals what? Now I'm going to work forwards in the problem, turning everything that I see into some sort of mathy equation-ness. So the length of a rectangle is 5 less than twice the width. So the length of a rectangle is, so length is translates to L equals 5 less than twice the width. Well, that 5 less than says I'm subtracting 5 from something, and twice the width means I'm subtracting it from 2W. That's cool, but not enough information for me to answer the final question. So I'm going to keep going in the problem and look for more clues. The perimeter must be at least 100 feet. So perimeter, I'll just write P for perimeter. And then at least 100 feet. That at least 100 feet means actually the perimeter has to be greater than or equal to 100 feet. That phrase at least means it could be 100 feet, but it could also be more than that. Well, great. Now I've got these 2 equations, but it's not quite enough to get us to something about the width. But we talked about this last week. We've got an equation for the perimeter, and I do expect you to memorize that. So our equation for the perimeter looks like twice the width plus twice the length. So I know that twice the width plus twice the length needs to be greater than or equal to 100 feet. And then, since we're trying to get the width by itself, it sure would be nice if we could get rid of the length in this equation. And we can with this other piece of information that we have. So I can replace the length with 2w minus 5. Now we've got an inequality. Now we can go mess with it. I'm going to go ahead and distribute that 2 through. So 2 times 2, that's a 4w minus 10 greater than or equal to 100. Combining my w's together, I've got 6w. I'll add 10 to both sides, so greater than or equal to 110. And when I divide by 6, this time I'm looking at that and saying, oh yeah, that is not in lowest terms. Let me take a second to put that into lowest terms. For sure, we can rewrite the 6 as 3 times 2, and that 110 as 11 times 10, or 11 times 5 times 2. So that my 2 over 2 becomes a 1, and w is greater than or equal to 55 over 3. Or if I wanted to write that out in words, oh, we should check for units. There were units in the problem, so we should have units in our final answer. And if I wanted to write that in words, I would say the width must be at least 55 thirds of a foot, or 55 over 3 feet. Just to practice like some of the phrasing. I said height is no more than 6 feet, then that phrase no more than would tell me that the height could be up to 6 feet, but it would have to be 6 feet or less. So I would say that the height was less than or equal to 6. I said, yeah, so at least no more than, I think greater than and less than are probably straightforward. We're just going to write the greater than or less than symbol. But I do think that the no more than and at least are the two that are sort of the trickier phrasings of things. Any last questions? Yeah, that's okay. Correct. So my office hours today, I'll go back to class. So I have office hours today over C class is on the 2nd floor of the Memorial Union. You can actually only get there from like the outside part of the Memorial Union. So if you're on the coffee house side, outside, there's a stairway that goes up to the 2nd floor, and C class is right there. Right. I'm in the conference room usually, although last Friday they kind of had me tucked around in the back. And then I also have office hours on Zoom today from 2 to 3. So those are my 2 times today. All of my office hours are in Canvas, and all of my in-person office hours are over there in the Chicanx Latinx Center. So come find me, come hang out. And you can ask me math questions, or you can just come and ask me UC Davisy questions. I've been here a long time. If you are having trouble navigating this university, I might be able to help. Okay. Bye, everybody. Nope. I got nothing for you. So